Now you try to do the last question, that is, if sigma r equal to 1 to 2n, AR x minus 2 to the power r is equal to sigma r equal to 1 to 2n, that is BR x minus 3 to the power r. And here AK is equal to 1 for all k greater than equal to n. Then prove that Bn is equal to 2n plus 1 c n plus 1. This is the question, and this is the last question of the binomial expansion. And if you want to get the more questions, then I will provide one paper for you, and you try those questions. Then you can solve. If you have the problems in that papers, then you can ask easily. But suppose if you want to do this, in that case, sigma is given there. Sigma, it means summation. Because of this, I just expand here. It means I am just eliminating sigma from here. Then I put here r equal to 1. Then we get a1. That is x minus 2 to the power 1. This is a2. X minus 2 to the power 2. This is, don't write here 1. You write there 0. Start from 0. Suppose a0 plus, this is x minus 2 to the power 2, r equal to 1, and a2 x minus 2 to the power 2, and that is a3 x minus 2 to the power 3, and this is a2n x minus 2 to the power 2n. And here that is b0, this one is b1 x minus 3, and this is b2 x minus 3 whole square, and just as b2n x to the power x minus 3 to the power 2n. Right? But we have to find bn. It means if we see this expansion, in that case, if b2 is here, then the power 2 is here. If b1 is here, power 1 is here. But if bn is here, then the power should be x minus 3 to the power n. Because of this, in this side, we are getting bn if the expansion is having x minus 3 to the power n. It means if we equate the coefficient of x to the x minus 3 to the power n, in this side we get bn. But in this side, this is very difficult to find the coefficient of x minus 3 to the power n. Because if we equate the coefficient of x minus 3 to the power n both sides, here we get bn, but in this side we can also get the coefficient of x minus 3 to the power n. But that will be very difficult to find this. Because of this, I want to make this question easy. Make the question easy. Because of this, I just suppose x minus 2 is equal to y. Then x minus 3 becomes 1 plus y. Right? Or x minus 3 is equal to y. Then x minus 2 becomes 1 plus y. Therefore, I put here x minus 2, whenever we are getting, we put here 1 plus y, then we get a0, that is a1, 1 plus y, and this is a2, 1 plus y square, and this is a3, 1 plus y to the power 2, and dash dash, this is an, 1 plus y to the power a, and this is an plus 1, this is 1 plus y to the power n plus 1, and up to a2n, 1 plus y to the power 2n. But in this side, we get b0, that is b1 y, and this is b2 y square, this is b3 y cube, and this one is b2n y to the power 2n. Right? Now we have to equate, but we already, there is given ak is equal to 1 for all k greater than equal to 1. Because of this, after an, all the coefficient like that an plus 1, an plus 2, an plus 3, and that is a2n becomes 1, because there is given in questions. For all k greater than equal to 1, it becomes ak is equal to 1. But after this, equate the coefficient of y to the power n both sides. But in this side we get bn, right? But in this side, here in this in two terms we will not have the coefficient of y to the power n. Here we will not have, and here we also not have. But in this, before this, we will not get y to the power n. But after this, we will get y to the power n in all terms. Suppose if we expand this is a binomial expansion because 1 plus y to the power n is given. But in this binomial expansion, the coefficient of y to the power n is, that is NCn plus. In this expansion, the coefficient of y to the power n is n plus 1cn. But after this, n plus 2cn. But in last, that is 2ncn. Right? It means the value of Bn is equal to this. But we have to prove the sum of this series is equal to this. Because in question, the value of Bn is given 2n plus 1cn plus 1. Now, this is NCn, but we can also write this. This is NC0 because the value of NCn and NC0 both are equal, because you know already the properties of combination NCr is equal to NCn minus R. Right? Therefore, this is n plus 1c1, this is n plus 2c2, and this is 2ncn is equal to Bn. Right? I use these identities in this question. Right? NC0, n plus 1c1, n plus 2c2, and that is 2n, Cn. But here you can also write this n plus 1c0. Right? And NC0, n plus 1c0, Ncn. Right? All the values are equal. Because of this, instead of putting NC0, we are just putting n plus 1c0 because the value of this is equal to 1. This is n plus 1c1, n plus 2c2, and dash dash 2ncn. But we have to find the sum of this series. And this series should be equal to 2n plus 1cn plus 1 hona chahiye, right? But Bn is equal to this. Now we have to find the sum of this. Because of this, I have to use the second identity of the combination. This NCr plus NCr minus 1 is equal to n plus 1cr. You have already studied the combination, but in that combination, these are the two identities which is very important. This is very important identities which we have to use in this question to solve this. Because of this, n plus 1c0, n plus 1c1, NCr minus 1, it becomes n plus 1cr. Therefore, this becomes n plus 2c1. Right? The sum of these two terms is n plus 2c1. But n plus 2c1 here and n plus 2c2 here, the sum of these two terms is n plus 3c2 here. After this, this is n plus 1, n plus 3c3. But the sum of this is n plus 1, n plus 2c1. But n plus 2c1 and n plus 2c2, it becomes n plus 3c2. But n plus 3c2 and n plus 3c3, that is n plus 4c3. And dash dash, if you come here, in that case, the sum of this series becomes, that is 2n plus 1 cn. Because up to here, we get the sum is n plus 3c2. Up to here, we get the sum is n plus 4c3. But up to this, we get the sum is 2n plus 1cn, and this is equal to Bn. But you can also write Bn is equal to 2n plus 1c, n plus 1, because I use here identities, this one, this identity is NCr is equal to NCn minus R. And this is the last question of the binomial and exponential series, right? And if you want to do the more questions, then I will provide one paper for you and try to solve the problems to see the papers. If you have any doubt, then you can ask easily. Right.